My name's Chuck Knox, and I'm going to put a small talk together on LIDAR and its use in the exploration of oil and natural gas. I use the USGS 3D portal to download my LAS files, and that's where I begin all my surveys, or with the USGS in this 3D EP portal. And LIDAR, it's way more than just elevation. Portal, this is if you go to the USGS, this is the screen you get to, and this is where you can learn about it and download the product. But I suggest to anybody that's it's getting ready to work on LiDAR is to this is where you start. 2013, this is the this is the data available to us when we started here, and the portal it was kind of clunky, wasn't working real good. I found myself going to the states and the counties and downloading data. Open topography, we were getting Indiana was that's where you would get it from. The Indiana data is open topography, but as time goes on, the 3DEP portal is just it works wonderfully for me, and that's every LAZ file I get comes from this portal. So I want to go through some of my projects that I've worked on and where I've started and where kind of where I've ended up. And each slide really deserves a talk, and we can't do that. This is just kind of a quick overview of what we're working on. But this one here is my first project. I was going through and then dug this thing up. This was the Royal Center gas storage field, and I had 3D. I knew where the fault was out here, the Royal Center fault, and I was trying to find something a correlation with using just a hill shade on the top, and it's very simple, and we got a little bit of correlation on it, but this thing really, this one is the one that got me going. It's not my best work, but it was early, and um, it's a handsome little thing. Here's a This was probably 2014 was working on. I was using terrain data sets. I'm now using Esri. I can download larger files, but I was noticing a correlation of slope angle and oil wells, and it's really what I was looking at. I think there's a bigger correlation between aspect and um, oil wells out in this area, but it really got me thinking about how we can start using this as an exploration tool. And I worked with Randy Billingsley with Monarch Crest out of Denver, and they had picked up this project, and I was able to work with Randy a bit on this, and he was such a wizard at Esri that I learned a lot by working with Randy. So thank you, Randy, for all your work on this second pay project. This came out from the IGS in this map. Well, it was probably 2015, I would guess, and this really shows how you can use elevation over large distances. You look, we've got the entire state in one image, one LAS data set, and we were able to make they were able to make a raster out of the entire thing. And this really changed the way I look at large data sets, because I knew that in Northeast Indiana is the intercontinental crust boundary is where it is. The great push from the southeast, of the Laurentia land mass crushing into the North American land mass, and the contact is in in northern Indiana, northeast and northwest Indiana, and you can clearly see from the DEM is in the northeast part of the state, the Packerton Moraine, where the 1600 contact had an influence on the melting of the glacier, and then as the water ran off, it actually influenced the Wabash River to the south and west. And so we have a 1.6 billion year old Precambrian feature that has an effect on sediments that are less than 16,000 years old. So we know that there is a constant changing of the surface due to subsurface conditions, and that's what we're trying to track with the lidar. By the at this point in time, it's probably 2016, and we're starting to use raster image rather than the terrain data sets, and getting some nice images of the surface. Here's the Glen Eyre field, and we've got a digital elevation model, and we get a little bit of a 3D look by having a transparent DEM overlaying a hillshade. This was we were using flow accumulation, and flow accumulation is a digital representation of stream flow. It's not where actually stream flow is, but it's where the Esri's spatial analysis can actually draw where stream flow should be from the digital elevation model, and this is a very valuable tool for us. Flow accumulation is probably the most useful tool that we have. It has made the jump into the machine learning, and we use this as a layer in our machine learning as well. And if you're a reef hunter, the flow accumulation is good. Is a good tool for you. This was a part of a study we did for a talk I gave up to Western Michigan University for the Michigan Oil and Gas Association, and it's on the southern reef trend. And this is in Calhoun County, and you can see that what we're doing is we're using the tools of the photogeologists of the past, and we're marking them. So we're taking digital data and then making observations and turning it into analog is what we're doing. And here's over, we can look at the reef trend over 4 counties. The signatures, this is over the DEM. We take out the DEM, and then we can see our reefs. Then let's put in the oil wells, and they're lining up quite nicely in here. So what this is the flow accumulation. It's a tool for 2D. So if you don't drill on this, it's what it is you go out and then you can find an area where to run 2D, then eventual 3D. Let me put in here we've thrown in the oil fields, and like I said, they line up quite nicely. We're looking at Northeast Indiana, and this is a 4 county survey we did up in the Michigan Basin, southern leg of the Michigan Basin, and this area is a fascinating area glacially, because we had the Lansing lobe from the north, and then the southeast was the Erie lobe. So we had actually 2 lobes meeting here. And as we remember from our 1600 line, this is where the great Precambrian feature is, and we're seeing the Packardin moraine right at this area. What we're looking at here is a digital slope elevation map is what this is, and we'll show how we put this together. Here's a close-up of the digital slope elevation map, and what it is it's an overlay of a digital slope direction model with this elevation DEM. Now here's our digital slope direction model, and this is pretty new. What it is, it's a way of using aspect and taking out most of the data 7/8 of the data, and then looking at the basically illuminating it one direction and the surface, and really some very fascinating features come to light when you do that. So if you look up at the legend up there, you can see we've broken this down in 1, 2, 3, 4, 5, 6, 7, 8 different directions. So you got north, northeast, east, southeast, and I black out everything, and then I illuminate it from one direction. And you look at the forces from the tectonic forces are coming from the south and east. So we're finding that if we illuminate from the south and east, we can start to see images of the surface that really we've never seen before. And when I talk about the fingerprints of the Earth, and this is what I'm talking about here, this northeast Indiana, you think of that 1600 line going through here, and you can see that from southwest to northeast. There was a lot of volcanics out in this area. We're seeing circular features out here that are most likely related to the volcanic activity. We're seeing the associated thrust faults with the 1600 line, and we're seeing the most importantly the wrench faulting, which is associated with the oil and gas of the southern Michigan Basin in the Ordovician. So we take that digital slope direction model, DSDM, and then we overlay it. I do a 45% transparency, and then you put the DEM over the top of it. And then you come up with this, and it's a really beautiful image of the area. It's got this nice crystalline look to it. The DS digital slope direction model that we use as the base of this, you it is these features were formed under the ice. We obliterated as the glacier melted. It obliterates some of these channels that you see in the model, and so we know that it was most likely a relationship between the ice and the soil when both were frozen and attached to each other. Now, what we've been working on now is how we use machine learning in the prediction of oil and gas, the occurrence of oil and gas. And this is again, the four county area. We've been using Landsat 9 data. We've been using Sentinel-2 data. And then we've been using the Lidar data. Like we said, the flow accumulation works out well as a input for our machine learning. And we've had pretty good success all over the country using these data sets. It's worked well down in Texas, in Nebraska, Kansas, Illinois Basin, Indiana, Michigan Basin, the Morrow County oil field out in Ohio. So this data travels well. What I want to look at is this signature right here. This is in the Ashley area. We've been working the Ashley area a long time. They've had wells back, trying to get oil out of this fractured reservoir back in the 30s, late 20s, early 30s. And as you can see, this Ashley area, it came out, it had a nice signature for it. So backtrack just a little bit here. Red is the predicted absence of petroleum, and black is the predicted presence of petroleum. So we're looking for an accumulation of these black pixels is what we're looking for, and it shows up well at Ashley. So here's Ashley. As you can see, I-69 running north and south, little town Ashley, and then Ashley Hudson. I want to throw in our digital slope direction model. And so there's a little tighter view of it. And this is the area we're looking at up here. And as you can see, we've got a bit of a cross going there. So we've got the thrust faulting from the southwest to the northeast, and then the wrench faulting from the northwest to the southeast. And it seemed like we're getting better signatures where we're getting these crosses, which makes sense. So is this a depiction of faulting in the subsurface, the jury's still out on that, but we're getting some good indications that there is a relationship. Now this is a soil gas survey, the results of it that we ran probably 2011 in the area. So this is old data that we've had for a while. And what I wanted to do is take this signature then and put it on the digital slope direction model. And as you can see there, it lines up quite nicely with it. There's a northwest southeast trend to it, and the lobe crossing the thrust faulting there. So we're seeing a good relationship between the soil gas analysis and the digital slope direction model. We also ran a really small 3D out in the area, and this is where we picked up the oil and gas indications. Actually, not oil and gas indications. This is where we picked up porosity in the Black River Formation, and as you can see, it lines up nicely as well with the digital slope direction model. Now I want to put in our predictive layer from the machine learning and throw those features in as well. So you can see this Ashley area right there. We've got a very nice signature right there. And we throw in our soil gas analysis, and it is lining up well with the black. You know, remember the machine learning is just a predictor, is what it is. Again, this is nothing to drill off of either. This is just a way to get us in and run some 2D and then eventually 3D. So it's a way to cut out, you know, if we can just cut out, you know, 95% of the acreage to run our seismic programs on, it's going to help tremendously in the cost analysis of that. And then we put in our little 3D right there. That's what we had. So this Lidar is a good tool in our machine learning. You know, the satellite data as well. So we're really using the digital nature of the LiDAR data and the satellite data to help us weed out areas and focus in on areas that are going to be productive of oil and natural gas. So I'm going to close by saying, embrace the laser, see the fingerprints of the earth. And I want to thank you all for fighting to the end here and seeing this presentation. Again, I'm Chuck Knox at Knox Geological. Thank you.